Good morning, students. So in the last class we have studied the static formula in order to find out the ultimate bearing capacity of pile. Okay, so I will summarize that portion. The static formula is like that is QU, ultimate bearing capacity. QU is equal to QP plus QS, that is end bearing resistance plus skin friction resistance, and end bearing resistance QP is equal to unit end bearing resistance QP into area at the base AP, and skin friction resistance QS is equal to unit skin friction resistance FS into surface area AS. That is, here AP means area of the pile at the base, so it will be pi d square. If d is the diameter of the pile, pi d square by 4 or pi r square, that is the area at pile tip. And AS means area which is in contact with the soil, so it will be actually the perimeter. That is, if D is the diameter and L is the length of the pile, this AS will be equal to pi into D into L. Okay, so this is the static formula, and this static formula is used for calculating bearing capacity of a pile, and this pile may be resting on cohesive soil or coastal soil. And for cohesive soil, the equation is like that is QP is equal to CNC into AP. Okay, and this equation comes from our Terzaghi's bearing capacity equation, that is CNC. Since it is cohesive soil, the first term will be only there, so CNC into AP, and this NC value will be 9 for piles. And QS is equal to alpha C into AS. Alpha is the addition factor, C is the unit cohesion. Okay, and for cohesionless soil, the C will be 0, so QP is equal to QNQ plus 0.5 gamma DN gamma into AP, and QS is equal to sigma KQ tan delta into AS. And here K is constant and its value is 1 to 1.54 board pile and 1 to 2 for driven pile. So in problem usually it will be taken as 2. Okay, so based on this static formula we can do some problems. First problem, a 15-meter long 400 mm diameter pile is driven in a uniform deposit of clay. Q is equal to 80 kN per meter square. The water table is at a great depth. Calculate safe load capacity of the pile with a factor of safety is equal to 2.5. Here we have to calculate safe load. So safe load is equal to ultimate load divided by factor of safety. So first we have to calculate ultimate load QU. So QU is equal to QUP plus QS, that is QP plus QS, point bearing plus skin friction resistance. So QP is equal to, since here the pile is resting on clay, that is cohesive soil. So what is the equation for calculating bearing capacity in the case of cohesive soil? That is QP is equal to CNC into AP and QS is equal to alpha C into AS. So by substituting these values, that is C is equal to so for calculating C is not given directly, but here QU is given as 80 kN per meter square. So we have studied that is if unconfined compressive strength is given, this cohesion value is equal to unconfined compressive strength divided by 2, that is C is equal to Q by 2, that is 40 kN per meter square. So C is 40 and NC that I have told, that is for pile, this NC is taken as 9. Usually for piles NC is equal to 9. Okay, so in some problems NC value will not be given, so you take NC as 9. NC 9 into area of area at the pile tip, so it will be equal to pi d square by 4 or pi r square, diameter 0.4 meter, that is pi into 0.4 square by 4, pi d square by 4, so 45.2 kilonewton is QP. Then QS, equation for QS, alpha C into AS. Then alpha means addition factor and usually it is taken as 1. Okay, in some problem it will be given. If it is not given, you take alpha as 1. Okay, and so substitute these values. 1 into C is 40 into AS. So AS means it is the area of pile which is in contact with the soil. So it is actually the perimeter, that is pi DL. So pi into d into L. L is the length of pile, that is 15 meter. So 754 kilonewton is QS. So QU is equal to QP plus QS. So 799.2 kilonewton is the ultimate load. So here we have to calculate safe load, that is ultimate load divided by factor of safety. 319.7 kilonewton is the safe load. Okay, I think it's clear. That is QU is equal to QP plus QS, and QP for clay CNC into AP. Then QS for clay alpha C into AS. Then substituting these values, you will get ultimate bearing capacity. Then ultimate bearing capacity by factor of safety is safe load capacity. So next problem, same problem. Here difference is that it is resting on sand. So a 15 meter long 400 mm diameter pile is driven in a uniform deposit of sand. Phi is equal to 40 degree. The water table is at a greater depth. Unit weight 18 kilonewton per meter cube. Calculate safe load capacity of the pile with factor of safety 2.5. So firstly we have to calculate ultimate load. This ultimate load is equal to QP plus QS. And for cohesive soil, for coastal soil or sandy soil, QP is equal to QNQ plus 0.5 gamma dn gamma into AP. Okay. But usually it will be driven pile will be driven into the soil, and the second term, that is, it is a surcharge component, and it will be usually negligible in the case of driven pile. So we can equate or approximate this value as Q and Q into AP. That's enough. Okay, this will be a smaller value. So QP is equal to Q into NQ into AP. Okay. And also in the case of driven pile, there is one effect which is known as arching effect. That is, arching effect will be occurring on sandy soil. That is, overburden pressure Q. Q is varying linearly up to a depth 20 D. Okay, that is, the overburden pressure Q is varying linearly up to a depth 20 D, 20 times diameter. Then it become constant up to the pile tip. Okay, that is a variation of overburden pressure in the case of driven pile. So up to 20 D it will be linearly varying, and after that it will be constant up to the pile tip. Okay, 20 D means 20 into here diameter 0.4 meter, that is 20 into 0.4, that is 8 meters. So this distance is 8 meter. So the remaining distance, since the total length is 15 meter, so here it is 7 meter. Okay, so QP is equal to here we have to calculate QP is equal to Q into NQ into AP. Q is equal to gamma into DF, that is gamma into this depth. Gamma is 18 kilonewton per meter cube. 18 into this depth is 8, that is 20 D. Okay, 20 D. So 144. So this 144 into NQ, for phi is equal to 40, NQ is 125. In university exam the values will be given, or otherwise the table will be provided. Okay, so 125 into AP. AP is equal to pi d square by 4. That is this value 2262 kilonewton. Okay. Next we have to calculate. Here we have calculated QP. Okay, so here overburden pressure is restricted up to the depth 20 D. So for this depth we are calculating overburden pressure, that is, this depth is 8 meters. So 8 into unit weight 18, that is 144. So we have calculated QP. Then QS is equal to sigma into KQ 10 delta into AS. So I have told K is usually taken as 2 in the case of dense sand. Okay, and delta means 40. So here it's two component, that is for 8 meter and for 7 meter we have to calculate, and for 0 to 8 meter this QS is equal to KQ tan delta into AS. Okay, AS means pi into D into L. So first we are calculating for length 8, that is this portion 8 meter. Okay, pi D into L. Okay, tan 40, and here it is area of this portion, that is half into this 144 into this height, half into 2 into 144 by 2. And for 8 to 15 meter, that is for this depth, it is 144 into 2 into K into Q, that is 2 into 144. Okay, here 144 by 2 becomes, because it is triangular portion, and here since it is rectangle, 2 into 144 into tan 40 pi into 0.4 into 7, since the length is 7. Okay, so calculate these two values, then add these two values, and you will get QS 3340. Then Q is equal to QP plus QS, that is the answer. And in question it's asked to calculate safe load. So safe load is equal to ultimate load divided by factor of safety, 2241 kilonewton. Okay. So this is the procedure for calculating ultimate bearing capacity using static formula, using static method. It is in static method, Q is equal to QP plus QS, that is end bearing resistance plus skin friction resistance. Sum of end bearing resistance and skin friction resistance is the ultimate bearing capacity of pile. Okay, so I think you have cleared about this equation and problem. If you have any doubt, please contact. Okay, thank you.